when you have two quantities, right, in the same, say, if we have two quantities here, one quantity x and the other quantity f, right? We say that they are directly proportional. Anybody ever hear that word before? Directly proportional?
No, sir.
Yeah, proportional. We never hear the first word we say. So.
Right. So directly proportional means that we have a chat here. Okay, no problem. Not a problem. We're going through it now. All right, no problem. Let's add these persons. Okay, so when two two quantities are directly proportional, in this case, f and x. Remember that k is a constant. K doesn't change this. Let's leave k right here. It's not changing. We're not troubling k. But f and x are in the same line, right? Or they are directly proportional. If if f was here and just for argument's sake, x was down here, right? This would mean that they're inversely proportional, right? So in a second here, it's that. Okay, good. So inversely proportional. I will explain both of them. Uh, I will explain both now.
Sir, can you repeat me just come, sir?
No problem. Go ahead. Question. All right.
So he's saying if you can repeat what you
Yeah,
said,
man.
so
No problem. No problem. I heard. So we're dealing with f and x here, right? F and x, right? We realize that they are in the same line, or they 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 co they coincide. So if we increase f on this side, then x will increase. We can do some quick tests on this. Why? Because if say we have two, let's do some quick algebra here quickly. We have 2x equal 4, right? 2x equal 4. The value of 4 would be what? X equal what? 4 over 2, right? So x is 2 in this case. Now, if we increase this value right here, if we increase the 2, or if we increase the 2 right here, let's put this at 3 and x is at 2, x is 2, right? 3 twos will be 6, right? For argument's sake, 3 twos will be 6. So therefore, if this increases, then the 4 would increase to 6. So if this increase to 3, let's do it again. If we increase the 2 to say 4, so the 2 would be x in this case. The 2 would be this with this value here, and the 4 would be the force. If we increase the the um the value of this 2 right here to 4, and then remember that this value is equal to 2, you would find that 4 twos 8, right?
Yeah, big man. I would cloud as a
Yes,
six.
sir.
No problem. No problem. Thank you. So 4 twos 8. Thank you for participating. All right. So 4 twos would be 8 in this case. So as we increase this 2 right here, this 4 also increase. So we say that the 2 and the 4 are directly proportional. As one increase, the other one increases. Now let's do the same thing for the other side. You understanding here? Directly proportional. You
Yes,
understanding?
Yes,
sir.
sir.
Yes,
All right,
sir.
beautiful. So let's say, for example, this is not true, right? But let's just do it for argument's sake, right? We have f and we have x, right? Let's say that we do the same thing over here, like what we just did, and we have our 2 over x. No, wrong. let's have our x over 2 equal 4. Now, if we increase this to 3, that will be complicated. Or let's increase this to 4. Let's increase this to 4. So we have x over 4 equal 4, right? No, that's not what I want to do. I'm gonna erase. That's not exactly what I want to do.
That's clear.
Let me rub this out over here. Get some more space over here. Right? That's not exactly what I want. Let's find the value of x first. Yes, that's what we were doing at first. Let's find the value for that x value. So x over 2 equal, say, let's put this one at 8 or 16. Yeah, let's put this value for 16. So x over 2 equals 16. Bear with me for a second. Just showing you something. If we find the value for x, right, we multiply both sides by 2, right? And we have our value for x as 32. 2 times 16, 32. For argument's sake. So our value for x is 32. If we increase this value of 2, so this value here and this value here are now inversely proportional. Let's prove that, right? And we have our x value as 32. So we place 32 here, and we increase this value to 4. Let's increase this value to 4, right? What will be this value over here? What will happen to this value? What would be this answer? You can send it in the chat, or you can use a
128, sir.
No, 32 divided by 4.
Okay.
128.
No,
Divided by 4.
Oh, divided by 4.
8. Right. So if we increase this 2 to 4, this value will go down. This value right here will decrease. Let's increase the 2 again now. Let's increase that to 8. So we have 32 over 8. Right? What will happen? What's the value of this now? What's the value over here?
32 divided by
4.
4, sir. 4.
4.
Man, them don't know the 8 times.
So if we
So why you never answer?
ready again?
Yes,
Yes, sir.
Yeah, so if we increase this 2 to 4, this will decrease from 16 to 8. And if we increase this 4 to 8, this will decrease from 8 to 4. So as we increase this value, this one decreases. So we say that they are inversely proportional. Understand now?
Yes.
All right. I hope we can remember this, right? But that was a long,
I'll try, sir.
yeah, man. So we'll just move on, right? We had to ensure that we understand. So as one of this value, right? We just proved it a while ago. As this value increases, you will find that this one will also increase. And we did that in the first experiment. As we increase the force, the extension also increases. Let's move on. So we have our units here. Of course, forces in newtons. We'll go through that next week. We'll go deeper down into force, right? And newtons. I'm sure you have heard that name before in grade 9.
Yes, sir. I'm kidding.
Right. And we have our extension here. Let's not spend too much more time on this, right? So we're moving on now. We have 13 minutes, right? So we'll see how much we can cover in 13 minutes. We are ahead, right, of schedule. We completed a lot today, and I'm budgeting that we'll just recap this the next time we meet. But we're ahead, so we'll just rush through this and then we can go through it again when we meet. Right. So we have our force. Right. Remember that we spoke about force. So this is our spring, right? This is our spring, and we have a kind of something to hold up the weight. So if we add weights to this, we call it a tray. So let's add a weight to the tray. You'll find that the spring extension will increase down, which we proved this already, right? So the force, what force is acting on the spring right here? What force is acting on the spring?
0.
No, like what kind of force is acting
Weight.
on the spring?
Which one again?
Newton.
Wait, sir, wait.
Right.
Let me say it.
Weight. I'm sorry, I didn't hear. So the weight causes the force to move down. So that means that weight is acting down. What causes weight?
Gravity.
Gravity. Perfect. So gravity is essential when doing Hooke's law calculation, right? Does the mass of the the mass changes, right?
Yes, sir.
The mass changes and mass is always constant. So please try and remember this, that mass never changes as it relates to a different, say we're on a different planet. We know that G will change, right?
Yes, sir.
You will
Yes,
get a
sir.
question on this on your activity for this week. G will not change, right? But the mass, the mass will not
Mass
change, but
not change.
G will be different. So you'll find a different value for weight, right? The G, we spoke about G last week. It's the acceleration
Acceleration
due to gravity, right?
Oh, yes, sir.
G. So just try and remember G. It has something to do with gravity, right?
Yes, sir.
G gravity. That's how I used to try and remember it. Right. So in order for us to find the force, this is the formula. We'll explain this further down next week and we'll go back into the details. But just remember that if you want to find the force acting on the spring, you will use, in this case, if the spring is going down, right, and the mass is exerting a force downwards. This would be our formula right here. F equal mass times the acceleration due to gravity, right? So we can quickly go through, as I said, we'll go through this again, but we can do a simple calculation, right? So we have our question here. So a car has a mass of 1.2 ton, right? The extension on the suspension and the spring of the car together, right? The springs and the car together has a spring constant of 2.0, right? Times 10. I'm I think this is 4. Yeah. I think this value is 4 right here. As a value of as to, let me go and check it and come back. All right, give me a second. Let's check it and come back.
Yo, Demarco. What's that, mids? Yo. But I'm mute mic. I never know what you're chewing about that.
Let me tell you that for back.
Hey! I will get that.
I was going to say, hey, so.
Hey!
Oh, that's all.
Yeah, I will get that. This is just a while ago.
Then but I think I record, I don't know.
Maybe didn't you, man?
But I look a joke, right? You know, like nothing serious. We must say, you have to have a little fun in that class.
All right. Okay. You hearing me?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Alright.
sir.
So I just got what my calculation. All right. So it is actually 5. This is
Oh,
actually 5.
10.
5.
10 to the 5. So you know about standard form? Have you ever seen this before? Times 10 to the 5 times 10 to the 2.
Yes, sir. No.
Right.
Yes, sir.
Okay, good. So we have our extension. Remember our formula? We need to find the extension of the spring, right? So we have our formula F equal Kx, right? And we want to find extension. What are we going to do here? We want to get x on one side. What do we do?
Going to divide K on both sides.
Divide k on both sides. Thank you so much for that. So x is equal to f over k, right? So now we're going to plug in our values. Now, what is one? We need to first convert this into force, right? We need force.
Alright, so now.
So our formula, remember, is F equal mass times acceleration due to gravity. So force is equal to mass times gravity, right?
Yes, sir.
Yes,
So,
sir.
A student and I waiting.
So 1.2 multiplied by
oh,
9.8.
no. Why? Because we still need to convert this to what? Why do we measure mass in?
Meter.
Meter.
No,
No, kilogram.
kilogram. So 1 kilogram is 1,000 kilogram is equal to 1 ton, right?
Yes, sir.
Yes, sir.
1 ton, kg, 1 t. So we want to find the amount of kilograms now. We want to convert this. So we have 1.2 here and we have x here. And if we cross multiply,
1,200 kilograms, sir.
1,200 kilograms. Perfect. So 1,200 times 9.8. What's the value we get for this?
Calculator.
So I get 9.8, sir.
9.8 is the acceleration due to gravity. Remember we spoke about this? Or we could
Oh,
run it
yes,
up to
sir.
10.
The Earth gravity.
Let's run it up to 10. Yeah, let's run this up to 10. We can run it up to 10. It is 9.8, but we can run it up to 10 so that the calculation is a little bit easier here in this case. If a question tells you that the acceleration due to gravity is 9.8, do not run it up to 10. Right? If they don't tell you, you're free to change it to 10, 9.8. The textbook says that. Right? So if a question tells you the acceleration due to gravity is 9.8, do not run it up to 10. So this is 10 right here. This is 10.
1200. 1200.
Right? Come again.
1200.
No, this is actually 1200. So 1200 times 10 is how much?
12,000.
12,000.
12,000.
My
God, add the zero, guys. Add the zero.
So why didn't you answer?
I'm black answer and I'm a tell you to add
No,
it
sir.
zero.
Me kind of it.
Alright. Alright. So this is 2.8 times 10 to the negative to the 5. We know how to change this to standard form. Do you remember?
Yes, sir.
How we do that?
12,000.
12
man,
times.
hands up.
12,000. And what?
You know how to
12.
change it?
12 times, sir. 12 times
12 times.
Yes.
100 today.
100 today.
Not exactly like we're going to do over some exercise with standard form. Right, we're going to have to do over some exercise with standard form. I'll place that in the activity, but for today, we're just going to just try and just finish this question, right? So I'll just go ahead. So we have our force. Our force is 12,000 newtons, right? And we place that here, 12,000 newtons over K, which is 2.0 times 10 to the 5. So we have 12,000 over 2.0 times 10 to the 5. So as I said, we'll go back through this question again, and then we'll look into standard form, right? This skill takes time, right? And I understand if you don't remember it, because it's been 7 months since you were in class, right? During quarantine. So, somebody just want to just quantify that for me. What is this equal to? X.
100. Oh shit.
12,000 divided by 2.0.
20, 300, 2,000.
Six.
Hmm?
Not 60,000.
Yes,
Not-
sir. 60,000.
It's not 60,000.
6,000, sir.
Not
That's
6,000
6,000.
either. It's something with 6, but as I said, we'll go back to it again. All right? We'll go back
Someone
to
close.
standard. No.
Then I will close.
Sir, 16.666.
16.
0.666.
No.
Sir, 600.
Baka may number that boy.
Not 600.
1,000, man. Saying that's
17. 17.
We'll
60.
go through it again. We'll go through it again. All right?
Yes, sir.
This answer, if we convert this, let's just convert this back to the original form and make it right again. So this is 2.0 times 10 to the
20,
5.
sir. Yeah, which is 20. Oh.
So this is
100,000, sir.
2, right? Point 0. So
Zero.
we're moving this back. So we're moving this 1, 2, 3, 4, 5. So we have zeros under here, right? So this now would be 12,000 divided by 2.
200,000.
So try it again now.
200,000.
Pine
Sir,
6, sir.
Go again.
Pine 6.
0.6. Right? No.
Got me
No,
good, sir.
no. Sorry, boy.
0.06.
0.06. All right, good. Good. We got there.
The close man, Papa.
We got there. Eventually. All right. So we're over time by 1 minute, 2 minutes. All right. So enjoy the rest of the day, everyone. If you have any questions, please let me know. I will post this in the group. Right. As I said, we'll do all the calculations again. We are far ahead of where we want to be. Right. I planned. We are halfway. We're more than halfway there for this week. For next class, we're going to go through the activity. If I go through the activity, I'm not taking any more assignments. That's just it, right? So I'm going to it tomorrow. You want me to go to it tomorrow? I want more time.
Tomorrow, sir. Tomorrow.
All right, so that means that I need it by tonight. I'm going to send a message in the group shortly for those who are not able to make it today. You will get the links for this on Google Classroom for this class. All right, so enjoy the rest of the day, everyone.
Yes, sir.
Yes, sir. Big up, big up.
All right, sir.
Nice.